Hello students, so here we are with the question first of the exercise 4.2 for the chapter Quadratic Equations. So the question first is find the roots of the following quadratic equations by factorization. And the two equations have been provided in A and B part. Before proceeding with the question, let us see what the roots mean. That is, as it's been asked in the question to find the roots of the quadratic equation. So in order to well understand this question, before doing the practical things about the solution for the roots of the quadratic equation, we will see what the meaning of roots is and also its significance. So now, in order to understand the meaning of the roots of quadratic equation, I'll be taking, say, example of equation. Say equation has been provided ax square plus bx plus c is equals to d. That is, it's a quadratic equation as the highest power of x is 2 and its coefficient is not equal to 0. So if I represent this equation in graphical form, say it is somewhat like this. Suppose the graphical representation of this equation is like this, right? So here we can see clearly that this graph, or I can say this graphical representation, cuts the x-axis, that is horizontal axis. I hope this is clear that the horizontal axis is called x-axis and the vertical axis are called y-axis. And this graphical representation of this quadratic equation cuts the x-axis at 2 points. This and this one. Let this be denoted by the variables x1 and x2. Okay. And as we see the quadratic equation being provided in the question, we know that the quadratic equation existence, or we can say in other words, the creator of the quadratic equation is the variable x. That is, if there is a variable x, then only there is some definition, or we can say existence of the quadratic equation. If there won't be the variable x, then this equation will not have a meaning to be called quadratic equation. That is, depending on the variable x only, this equation is called quadratic equation. Its existence depends on the variable x, right? Or we can say in other words, x is the creator of quadratic equation. So, if the graphical representation of the quadratic equation cut the creator at any point, that point is called the root of that quadratic equation. I hope this is clear what I said. I mean, as in this very example, I have assumed that this graphical representation of the quadratic equation cut the x-axis, or I can say creator of this quadratic equation at points x1 and x2. Therefore, these points will be called the roots of this very quadratic equation, that is ax square plus bx plus c is equals to d. So this is the meaning of the roots of quadratic equation. That is, we need to find those values for the variable x at which the graphical representation of the quadratic equation cuts the x-axis. Okay. So I hope this is clear that what exactly the meaning of roots is. So now coming to the question, here the first quadratic equation being provided is x square plus 3x minus 10 is equals to 0. So in order to solve any of the quadratic equation, say here also I am taking example, say ax square plus bx plus c, I need to do the middle term splitting. Now what the middle term splitting means? Means I need to split the coefficient of x into two coefficients, say p and q, such that their product, that is, also as I know, the sign of the p and the q can be either positive or negative. That is, might this be the case that p is positive and q is positive, or this may be the case that is p is negative and q is also negative, and this can also be the case that p is positive and q is negative. there is also the possibility that the variable, or I can say the coefficient, it's not a variable, it's a constant coefficient term, right? So it's also the possibility that the P has a sign negative and Q at that very time has a sign positive. Means in turn of the signs, we have four possibilities, right? So I can represent P as plus minus, that is, it can take any sign, and also Q can take any sign, either positive or negative, depending. Now, on what condition the signs depend is the product of P and Q needs to be equal to the product of the coefficient of x square and constant term, that is AC. And also their sum needs to be equal to B, that is coefficient of x. Depending on these two conditions, the value for P and x as well as their sign has to be determined. And after determining the sign and the values for P and Q, those values becomes the factors of the quadratic equation, and we can easily find its root by equating this equal to 0. What I mean, I'll be showing this by doing the example here. Now coming to the first quadratic equation, here the equation being provided is x square minus 3x minus 10 is equals to 0. So as we have done in this very example, that is earlier example, that we need to do the middle term splitting, and as the middle term in this case is minus 3. So first the step I'll be doing is to find the two terms such that their sum represent the middle term of the quadratic equation. So for 10, we know that it has only two factors, that is 5 and 2. So I can split the middle term of the quadratic equation in terms of 5 and 2 only. So what their sign will be, now the question arises. Their sign will be such that their sum will be equal to minus 3 and their product is equals to minus 10, that is A into C. So here I'll be writing x square minus 5x plus 2x minus 10 is equals to 0. So minus 5 plus 2 comes out to be equal to minus 3, and minus 5 into 2 comes out to be equal to minus 10. Means these terms are perfectly okay to obtain the middle term splitting. Okay. Now, if I observe the first and the second term, I can take x common. So here I'll be left with x minus 5. And if I observe the third and the last term, here I can take easily plus 2 common, and I'll be left with x minus 3 in the bracket. It's x minus 5, as 2 into 5 is equals to 10. So I can write it as x minus 5 into x plus 2 equals to 0, right? And as I know, these two terms product can be 0 only and only if either of the two terms is equals to 0. So I'll be equating each term individually equal to 0. So I'll be getting the value for the x variable to be 5 or minus 2. So these are the values for the variable x, or I can say these are the roots for this very quadratic equation. That is, this quadratic equation might be cutting the x-axis at 0.5 and minus 2 respectively. This is what the roots means. Now coming to the B quadratic equation, here the equation being provided is 2x square plus x minus 6 is equals to 0. And again, I need to do the middle term splitting in order to get the factors, or I can say in order to get the roots of the quadratic equation. And as the middle term is plus 1, so if I factorize the product 2 into minus 6, that is 12, ignoring the signs here. So here it will be 2, then 2 and 3. Means these are the prime factors for the number 12, that is product of A and C. So I need to combine these factors in two factors such that their product is equal to A into C and their sum is equal to B in according to the standard representation of the quadratic equation. So here I'll be getting 2x square plus 4x minus 3x minus 6 is equals to 0. Now, if I observe the first and the second term here, I can easily take 2x common. So in the bracket, I'll be left with x plus 2. And if I observe the third and the last term, I can take minus 3 common. So I'll be left with x plus 2, which is equals to 0. Or I can write it as x plus 2 as it's common in both the terms. So here I'll be left with 2x minus 3 is equals to 0. And as we know, the product of the two term is equals to 0 only and only if either of the term is equals to 0. So equating each term equal to 0 separately, the x comes out to be equal to minus 2 and 3 by 2. Means these are the roots of this quadratic equation, or I can say the graphical representation of this very quadratic equation cuts the x-axis at point minus 2 and 3 by 2 respectively. So this was about the first and the second part of question second. We will be proceeding further with another parts of question first. Now coming to the third quadratic equation of question first, here the third equation is root 2x square plus 7x plus 5 root 2 is equals to 0. So as we know, in order to find the roots of this very quadratic equation, we need to do the middle term splitting. That is, we need to split the term plus 7 in two terms such that their sum comes out to be equal to 7 and their product is equal to a into c, where a is root 2 and c is 5 root 2 in this case. So the middle term will be split in such a way that here I get the two terms 5x plus 2x, as clearly their sum comes out to be equal to 7x and its product is equal to 10x square. Same as that of the terms, that is a into c. So here I'll be writing the third term now, that is 5 root 2 is equals to 0. Now if I observe the first and the second term, here I can take x common. So I'll be left with root 2x plus 5. And if I observe the third and the fourth term, I can easily take root 2 common from both the terms. Here in the bracket, I'll be left with root 2x plus 5, which is equals to 0. So I can write it as root 2x plus 5, x plus root 2 is equals to 0. And as we know, the product of the two term is equals to 0 if either of the two term or both the terms are equal to 0. So what I'll be doing here is I'll be equating each term equal to 0 individually and find the value of x. So by equating each term equal to 0, here x value comes out to be equal to minus 5 by root 2. And the second value for the x variable is minus root 2. So these are the roots of this very quadratic equation, or we can say these are the points at which the graphical representation of this quadratic equation cuts the x-axis. So this was about third quadratic equation. Now coming to the fourth quadratic equation, here equation being provided is 2x square minus x plus 1 by 8 is equals to 0. If we observe this very quadratic equation, it seems to be something different than the equations we have solved earlier. Why? Because the constant term is in rational form. It's not in integral form, right? So I'll be equating this equation in such a way, or I can say I'll finding the roots in such a way that this won't create any problem. So what I'll be doing here, I'll be dividing both the sides by 2. As dividing both the sides, that is by equation and the 0 term by 2, it won't make any difference to the equation itself, right? So dividing both the sides by 2, I'll be getting 2x square minus x plus 1 by 8 divided by 2, which is equals to 0 divided by 2. That is dividing both the sides by the number 2. So here left hand side comes out to be equal to x square minus x by 2 plus 1 by 16, which is equals to 0. And if I observe the first and the third term of this very equation which I have obtained, I can easily apply the identity a minus b whole square because the middle term is equal to 2 into a into b. That is a in this case is x and b will be 1 by 4. That is I can write 1 by 16 as 1 by 4 whole square. Right. So here a comes out to be equal to x and b comes out to be equal to 1 by 4. And if I apply the identity a minus b whole square, then the middle term is same as that, equal to minus 2ab. So applying the identity, that is here, first let me write this equation in that form. Here I'll be writing 1 by 16 as 1 by 4 whole square, which is equals to 0. So now applying the identity, that is a minus b whole squares, where a is x and b is minus 1 by 4. So it will be like this, which means x minus 1 by 4 into x minus 1 by 4 is equal to 0. Right? As two same terms product comes out to be power 2. So I can write this in this form also, that is splitting the two terms from the square one. So if I equate each term equal to 0, as we know that the product is equal to 0 only and only if either of the term is equals to 0. So equating each term equal to 0, I'll be getting two values of x which are 1 by 4 and 1 by 4. That is same values for the x, but 2 times. Just remember. So 1 by 4 is the root of equation 2x square minus x plus 1 by 8 is equal to 0. Means the graphical representation of this very quadratic equation will definitely cut the x-axis at one point, because these 2 points are not different but the same value, that is 1 point itself. So that equation will be cutting the x-axis at one point whose value is 1 by 4. So this is what the roots of this equation means, or I can say the values of the x represent for this very equation. Okay, now coming to the E part, here the equation being provided is 100x square minus 20x plus 1 is equals to 0. So again, in order to find the root of this very quadratic equation, I need to do the middle term splitting. That is, I need to split the middle term into two terms such that its sum is equals to b and its product is equals to a into c. Right, comparing this equation with the standard quadratic equation. So splitting it, I'll be getting here 100x square minus 10x minus 10x plus 1 is equals to 0. So on observing the first and the second term, I can take 10x common. So I'll be left with 10x minus 1. So in the third and the fourth term, I'll be taking minus 1 common. So in the bracket, I'll be left with 10x minus 1. So I can write this also as 10x minus 1, 10x minus 1 is equals to 0. Now equating each term equal to 0, so I'll be getting two values of x. Those are 1 by 10 and another one will also be 1 by 10. Means the two roots which have been obtained for the fifth quadratic equation is the same value, that is these two roots are not different but one root itself, right? So what it means is that at point x is equal to 10, the graphical representation of this quadratic equation must be cutting the x-axis, right? So x is equal to 10 is the root of this quadratic equation. This was about the first part of the exercise 4.2. I hope this question is clear to all of you.